Propellers have been a fundamental component of aviation for over a century, powering hundreds of aircraft forward with the sheer power of rotating blades. But what if I told you that there is a new propeller prototype that could challenge everything we know about aerodynamics, efficiency, and maneuverability? The toroidal propeller, also known as a donut or ring propeller, is a marvel of engineering that boasts a groundbreaking design inspired by nature. Its unique circular shape and hollow center promise to unlock a whole new level of performance and efficiency in aviation. Its development took place at the NASA Glenn Research Center in Cleveland, Ohio, which has a rich history of pioneering research and development in aerospace technology. As one of NASA's premier research facilities, Glenn Research Center focuses on various areas of aviation, including propulsion systems, aerodynamics, and advanced engineering. The center's state-of-the-art testing facilities, such as wind tunnels and computational modeling tools, provided a platform for in-depth analysis and optimization of the toroidal propeller's performance. What makes the toroidal propeller so remarkable is its ability to generate lift and thrust simultaneously. This ingenious design is not only a better way to harness the power of air circulation, but also a highly efficient manner of doing it. So how exactly does a toroidal propeller work? What are its design principles? What are its aerodynamic advantages? Most importantly, how would this breakthrough in aircraft propulsion reshape the skies above? The toroidal propeller derives its name from its distinctive circular shape, reminiscent of a torus or donut. What makes it so different, you might ask? Traditional propellers use rotating blades that generate lift and thrust to create airflow over their surfaces. Unlike conventional propellers, which rely on separate mechanisms for lift and propulsion, the toroidal propeller ingeniously combines both functions into a single design. Its unique circular shape and hollow center allow for continuous airflow, resulting in improved aerodynamic efficiency. By reimagining its shape and airflow dynamics, researchers and engineers sought to address challenges such as energy losses, turbulence and noise, and maneuverability. How does it work? To understand the principle of air circulation and its role in the toroidal propeller's operation, let's delve deeper into how it generates both lift and thrust simultaneously. As the toroidal propeller rotates, it interacts with the surrounding air, creating a dynamic airflow pattern. This airflow pattern powers the necessary lift and thrust for the aircraft. Meanwhile, on the upper surface of the propeller, a low-pressure zone is created. This occurs due to Bernoulli's principle, which states that as the speed of a fluid, or air in this case, increases, its pressure decreases. The rotation of the toroidal propeller causes the air to move faster over the curved surface, resulting in lower pressure than the surrounding air. At the same time, a high-pressure zone is formed on the lower surface of the propeller. The air is compressed due to the curvature of the propeller, resulting in increased pressure. According to the principles of aerodynamics, this pressure difference creates an upward force that opposes the weight of the aircraft. The lift generated then allows the aircraft to ascend into the air. The toroidal propeller showcases a number of aerodynamic advantages. For one, it exhibits enhanced thrust efficiency by eliminating traditional blade tips found in conventional propellers. These blade tips are prone to vortex formation and associated drag, which leads to turbulence and energy losses. By eliminating them, the toroidal propeller reduces turbulence and improves thrust efficiency, resulting in higher speeds and increased fuel economy for aircraft. 2. Its ingenious design allows for better maneuverability. The toroidal propeller directs air both downwards and rearwards, providing better control over the aircraft's pitch, yaw, and roll. This increased maneuverability is crucial during critical flight stages, such as takeoff, landing, and challenging conditions like strong crosswinds. More importantly, this new design enables pilots to make precise adjustments to maintain stability more effectively, ensuring safer and smoother flights. Additionally, its circular shape will finally eliminate the annoying sounds traditional propellers make. This contemporary mechanism plays a crucial role in reducing noise and vibrations. The absence of blade tips, which are a significant source of aerodynamic noise, significantly contributes to a quieter flying experience for passengers. This reduction in noise pollution will make traveling on board more comfortable and coexisting within communities surrounding airports more amicable. So how exactly will this propulsion game changer reshape aviation? In commercial aviation, the toroidal propeller holds immense potential. Its ability to improve fuel efficiency and reduce emissions aligns perfectly with the industry's increasing focus on sustainability. Airlines could significantly reduce their carbon footprint and operating costs by retrofitting existing aircraft or designing new planes around the toroidal propeller technology. The potential to fly farther, faster, and greener would not only benefit the environment, but also transform the commercial aviation landscape. In the realm of general aviation, the toroidal propeller offers numerous numerous benefits to personal aircraft, small planes, and helicopters. The enhanced maneuverability and fuel efficiency of these aircraft would empower pilots to explore new routes, reach remote destinations, and reduce operational expenses. Moreover, the reduced noise and vibrations associated with the toroidal propeller would contribute to a more enjoyable and peaceful flying experience for pilots and passengers alike. The toroidal propeller's advanced maneuverability and improved efficiency have also attracted attention in military applications. Combat aircraft equipped with this propeller technology could gain a significant tactical advantage. The increased maneuverability allows for tighter turns, improved evasion capabilities, and enhanced agility in aerial combat scenarios. Additionally, the toroidal propeller's reduced noise signature makes aircraft less detectable by enemy radar systems, enhancing stealth capabilities. These advancements could reshape military aviation strategies and provide a critical edge in modern warfare scenarios. The rapidly growing field of unmanned aerial vehicles, or UAVs, could also benefit greatly from the toroidal propeller. UAVs are increasingly utilized for various purposes, including surveillance, delivery services, and passenger transportation. By integrating the toroidal propeller into UAV designs, operators can benefit from increased flight endurance, improved stability, and greater payload capacity. These advancements would unlock new possibilities for applications such as long-range missions, emergency response, and aerial exploration. Furthermore, the toroidal propeller's design principles make it well-suited for vertical takeoff and landing aircraft. The ability to generate lift and propulsion simultaneously enables efficient vertical takeoffs and landings, eliminating the need for extensive runway infrastructure. VTOL aircraft equipped with toroidal propellers could revolutionize urban transportation, providing faster and more flexible options for commuting and reducing congestion in crowded cities. As the toroidal propeller technology continues to evolve and mature, its impact on aviation across these domains will become increasingly profound. The potential for improved fuel efficiency, enhanced maneuverability, reduced noise, and expanded capabilities in areas such as commercial aviation, general aviation, military applications, UAVs, and VTOL aircraft would usher in a new era of aviation. With the toroidal propeller at the forefront of this transformation, the skies above would be characterized by faster, greener, and more versatile aircraft, paving the way for an exciting and sustainable future in aviation. While the toroidal propeller holds remarkable advantages for aviation, there are significant challenges that must be addressed before its widespread adoption becomes a reality. For one, its complex design requires intricate engineering and manufacturing processes. The precision and accuracy needed to create the circular shape, maintain the hollow center, and achieve the desired aerodynamic properties present challenges in production. Manufacturing techniques must be developed or refined to meet the specific requirements of the toroidal propeller, ensuring consistency, reliability, and durability. Structural integrity is another critical consideration. The toroidal propeller must withstand the stresses and forces experienced during operation, including the high rotational speeds and aerodynamic forces. Rigorous testing and analysis are necessary to ensure the propeller can withstand these conditions without compromising safety or performance. Advancements in materials science also play a crucial role in developing the toroidal propeller. Lightweight and high-strength materials that can withstand the stresses of operation are essential for achieving optimal performance. Research into novel materials and manufacturing techniques will enhance the propeller's structural integrity and efficiency. Lastly, optimizing the toroidal propeller's design and performance for different types of aircraft is a complex task. The propeller must be tailored to suit various aircraft configurations, sizes, and weight distributions. Each aircraft presents unique challenges, such as balancing lift, thrust, and stability requirements. Extensive research and development efforts are needed to adapt the toroidal propeller design to suit specific aircraft types while maximizing efficiency and performance. The toroidal propeller has emerged as a groundbreaking breakthrough in aviation propulsion, captivating experts worldwide with its revolutionary design principles and remarkable advantages. Its ability to generate simultaneous lift and thrust, coupled with enhanced efficiency, improved maneuverability, and reduced noise and vibrations, has the potential to reshape the very fabric of the skies above. As this technology continues to advance and mature, the toroidal propeller holds tremendous promise for a wide range of aviation sectors. In commercial aviation, it offers the potential for significant fuel savings, reduced emissions, and increased operational efficiency. efficiency, aligning perfectly with the industry's growing emphasis on sustainability. General aviation stands to benefit from enhanced maneuverability and cost savings, empowering pilots to explore new routes and reach remote destinations. Military applications could see heightened tactical capabilities and enhanced stealth, revolutionizing aerial combat strategies. Unmanned aerial vehicles, UAVs, could experience extended flight endurance, improved stability, and expanded payload capacity. And the advent of toroidal propellers in vertical takeoff and landing aircraft could revolutionize urban transportation, providing faster and more flexible commuting options while alleviating congestion. The future holds great promise for the toroidal propeller as collaborations between aerospace companies, academic institutions, and research organizations drive innovation and overcome challenges. By leveraging advancements in aerodynamics, computational modeling, and materials science, the design can be refined and optimized for different aircraft types, ensuring structural integrity and maximizing performance. In the not-so-distant future, we may witness a transformation of the skies, where toroidal propellers grace tomorrow's aircraft. Faster, greener, and more versatile transportation will become a reality, revolutionizing travel. The toroidal propeller stands as a beacon of innovation, propelling us towards a future where aviation is more sustainable, efficient, and exciting than ever before. The journey has begun, and with the toroidal propeller leading the way, we can soar toward a new era in aviation. In what other ways could the toroidal propeller influence the future of aviation? Let us know in the comment section down below. And if you enjoyed this video, don't forget to hit the like button and subscribe to our channel.